Welcome to my channel. Hope you all are doing good. So in this video, we will discuss about the ligands and what is central atom or ion, which is important for the transition metal chemistry. So first of all, ligand. So ligand is an atom or a molecule or ion which is capable of donating a pair of electrons to the central metal or a ion. So what does it mean? So what is a ligand? Ligand is something which will be able to donate the pair of electrons. So ligand can be a neutral thing, like if I say NH3, ammonia. So nitrogen has a lone pair and nitrogen can donate this lone pair to the metal. So this can act as a ligand. Similarly, if I take a chloride ion, Cl negative, so it has a negative charge, it can donate this negative charge to any metal. So it can form a coordination bond with the metal. So this can also act as a ligand. So there can be like bigger ligands. These are monodentate. Soon we will discuss about them. Next, we have central atom or an ion. So atom or ion to which a fixed number of neutral molecules or ions are attached in a coordination entity is known as central metal atom. So central atom is mostly a metal like say transition metals, for example, iron, cobalt, manganese, etc. So for example, I have iron and here I have some A group attached. Here I have some B group attached, C group, D group. So this is my central metal atom. So central metal atom. So now this can be charged or neutral species. Suppose iron can be iron 2 oxidation state or 3 oxidation state, or it can be in 0 oxidation state. It depends on these ligands, like what type of ligands are bound to it. I hope this is clear. Okay, ligand is something which donates the electron pair, and the central atom is something which will accept the electron pair and will form a coordination sphere. Now, what is a coordination sphere? Basically this whole compound we termed as coordination sphere. Okay, now let's move further. So here I will discuss few examples. Okay, you need to answer. Suppose I take a complex like nickel, NH3, 6, 2 positive. So here guess the central metal, central ion and the ligand. So nickel 2 positive would be my central atom or central ion, and NH3 would be my ligand. Correct? Okay, now your turn. Okay, guess this. Pause the video and guess it. So here, this central ion is cobalt 3 positive, which would be my central ion. And the ligands are Cl negative and NH3. So these are my ligands. Let's do one more example. Okay, pause the video and guess. Here, nickel 2 positive is my central atom. And Cl and H2O are my ligands. Okay, I hope this concept is clear. Now, next we will discuss types of ligands. So the very first type are unidentate. So uni means one. So which can coordinate to the central ion through only one donor atom. So they just have one donating site. So basically mono, they are also known as monodentate, and mono means single. They have a single donor atom, just one donating atom. For example, NH3. So ammonia. So here there is one donating atom, which is nitrogen. Nitrogen will donate 2 electron pairs. Correct? Next we have H2O, water. So oxygen. So oxygen has 2 lone pairs, but remember, oxygen just donate 1 lone pair. Oxygen won't donate 2 lone pairs. So this is the donating side. It can bind with the metal to form a coordination bond. Next, we can have Cl negative. So it will donate via its negative charge. Next, we can have cyano group, N negative. So here a donation can be from this negative charge, OH negative. And we can have O2 negative, N2 negative. And these are charged, correct? Charged atoms. We can have neutral also, like CO, carbon monoxide. So it is a monoxide. So it is a neutral donating ligand. Okay, so these are also neutral. Ammonia is neutral. Water is neutral. They fall under the neutral category. So they just donate via one atom. So there is only one donating site. Next, we have bidentate. So ligands which have two donor atoms and therefore can coordinate to the central ion at two positions. So now bi means two. So bidentate means two donor sites. They have two donor atoms which will bind to the single metal atom. So let us take an example. Let us take ethane dioate. Now how to make the structure? So ethane means CH2, correct? But there is dioate. This is an ester group. So make two carbons and then an ester group. Ester group is this. So this is the structure. So what will happen? This is one single ligand. So it has two donor sites now. One oxygen, this oxygen number 1, and this is the oxygen number 2. So here you will have a metal atom. This oxygen will donate and this oxygen will donate. So after donation, what will happen? It forms a ring. If you can see here, this is a ring now. So ring contains metal atom, first member of the ring, second member of the ring, third member of the ring, fourth member of the ring, and fifth member of the ring. So it forms a ring, correct? So it is ethane dioate or oxalate. The other name for this is oxalate, derived from oxalic acid, ethane dioate. So this could be one example. Let us discuss another example of bidentate ligand. Next could be CH2, NH2, NH2. So this, the name is ethylene diamine. So from where it will donate? What is the donating site? Pause the video and tell me. So here the donating site is nitrogen. Nitrogen has lone pairs. So it will donate via lone pair. So here one metal will attach and here they will form a ring like this with the metal. Okay. So two donating sites means bidentate. So this is a neutral donating site. Next, let us take one more example. We can have char species also. So under the char species, we have glycinate. So see, structure would be CH2. This is the structure. So it will donate via lone pair of nitrogen and this negative charge. And here would be a metal. So it will form a 4-member ring. So glycinate ion. Okay. So we discussed 3. Fine. Which one? Ethane dioate, ethylene diamine, and glycinate ion. Now you know that bidentate ligands can be categorized as symmetrical and unsymmetrical. So symmetrical would be ethylene diamine. So what is the structure of ethylene diamine? This is the structure. So this is a symmetrical group. Why symmetrical group? Because both the donating sites are same. From here also it is NH2 and from here also it is NH2. When the donating sites are same, they are termed as symmetrical. And when the donating sites are different, like in the glycinate, one site is NH2 and the other site is COO negative. So this is unsymmetrical, correct? Unsymmetrical. So this is known as as unsymmetrical things. So glycinate is an example of unsymmetrical. Okay. So next, third category, we have polyatomic or polydentate ligands. So ligands having more than 2 donor atoms present in a molecule. So in a single molecule, they will have more than 2 donating sites. These may be tri, tetra, hexa, penta, depending upon the number of donor atoms present in their molecule. So just remember one thing, the other name for the polydentate is multidentate. So they can form a maximum of 6 bonds. So the other name for them is multidentate. Multidentate, and maximum would be 6, which is hexadentate. Not more than 6. Tri means 3, tetra means 4, penta means 5, and so on. Now let us discuss the example of polydentate. Okay. So the example of polydentate is a very famous example. I will write the name first. Ethylene diamine tetra acetate. So see the name ethylene. Ethylene means CH2 group. So CH2. Then diamine. Amine means nitrogen. So 2 nitrogens. Then tetraacetate. Acetate group is CH3 COO negative. So 4 acetate groups. Tetra means 4. So 4 acetate groups. So 2 here. Correct? So this is the structure. Now what are the donating sites? Pause the video and guess the donating sites. So here is a negative charge. So this is my first donating site, negative charge, second donating site, negative charge, third donating site, negative charge, fourth donating site. But we have lone pairs of nitrogen also. So fifth donating site and the sixth donating site. So it is a hexadentate ligand. So it is commonly known as EDTA. EDTA. Okay, it is a hexadentate ligand. It binds through 2 nitrogen and 4 oxygen atoms to the central metal ion. Like you have a metal are there. So nitrogen, this, and this. They all will bind together. Okay, hope this is clear. Now, nature is really amazing. So we will discuss one naturally occurring polydentate ligand, which is our porphyrin ring. So this is also in your syllabus. We will just go through it. So this is porphyrin ring. So it has nitrogens. Nitrogen has lone pairs, correct? So the metal can bind through these lone pairs. Here we can have a metal ion. Metal can bind through these. So what happens when the metal binds to the porphyrin ring? So when metal is iron. So when metal is iron, Fe, in the 2 oxidation state, and here we have some substitutions, like here, we have some kind of substitutions. So this structure which give rise to this, here you can see. So this, when iron binds to this porphyrin ring, it forms the heme group. We call it as a heme group. It is present in our hemoglobin. So it is a complex formed by porphyrin ring and iron in +2 oxidation state. So this is a polydentate ligand donating from 4 sides binding to the metal. Okay. So now what happens? So in this, what this complex do, it has iron in +2 oxidation state. And you know what is the function of hemoglobin? Hemoglobin is used for, yeah, correct. Hemoglobin is used to transfer oxygen. So this, here we have central metal and iron. So oxygen will bind to this, O2 will bind to this, and it is transported by the heme group. So now you know there is a like a fact which says that carbon monoxide has a greater affinity to bind to the heme group. So this whole is a heme group. So this other than this O2, carbon monoxide can also bind. Like suppose you are like in a environment where there is a evolution of carbon monoxide. So what will happen if you will consume carbon monoxide? The carbon monoxide will go inside your blood and it will bind with this heme group. So out of O2 and carbon monoxide, the heme group has more love towards the carbon monoxide. So carbon monoxide will bind to this heme group more nicely. It has like 200 times better affinity. So it forms a stable complex than this oxyhemoglobin. If O2 binds, we call it as oxyhemoglobin. So the complex formed by carbon monoxide has a greater affinity. So what happened? This causes a condition known as uh, hypoxia, means insufficient oxygen supply to the tissues, and which can later cause tissue death. So this is a naturally occurring polydentate ligand. Fine. This is the ligand. When metal binds to it, it is known as heme group. Just remember. So this is my porphyrin ring. It is a multidentate ligand. When metal will bind, when the metal is iron in +2 oxidation state, we call it as heme group, which transport oxygen. I hope this is clear. Okay. So if you like the video, do subscribe the channel and share it. And one more important information, we also provide one-to-one lectures in chemistry on any topic that you want. You can contact us through the email. I will, the link, the email is given in the description box. Okay, thank you. Happy learning. Bye-bye.